Good morning, everyone. I'm Alina from Davier, and I am going to present something that is a bit different than what is in the volume with our abstracts. And part of the reason is that this is the most recent work that I've been doing at ACT, and I thought I'm just quite interested in it, and I thought it would be of interest to you as well. You want me to do this? That one is not as good. Okay. Okay. How is this? Is it better? Better? Yeah? Okay. So I will talk about a different way of thinking about learning and assessment systems and what it means for them to be adaptive. The outline of my presentation is I will talk first about ACT Next. This is my group at ACT, and about how we incorporate the knowledge about CAT and MST together with intelligent tutoring systems with eventually collaboration, about adaptive recommenders algorithm for machine learning. And then I will present a specific project that we call the missing link. And I will emphasize the type of conceptual framework and the type of thinking around these issues at ACT. So ACT Next is a new division at ACT, and it's an innovation center because it includes research development, but also business innovation. And it is dedicated to developing groundbreaking learning and assessment systems that can be used at scale in authentic real-world scenario. And the three elements that we emphasize are computational psychometrics. Okay, this doesn't work. What about this? Not it. Okay. Not. So computational psychometrics, system development, and business innovation. So they have to go together, and this is what we are emphasizing. Now, what are the main differences between adaptive testing and adaptive learning? So in some way, you can think of it as a difference in the objective function. So for testing, we need to estimate the ability as accurately as possible. So for example, we have the Fisher information or entropy measures that are used to select the next item. But for learning, we actually need to increase the ability. So other types of indices are more useful for the purpose of learning. So the major difference is in the content for testing and the one for learning, because in the terms of learning, you may want to have not just simple items, you might have to have more complex tasks that target particular misconceptions. So the content tends to be a big difference between the two. So the projects on adaptive learning and assessment systems use different types of adaptivity, but with a twist. So the selection of the next instructional module becomes an important part in the adaptive learning framework. And here we look into recommender algorithms that are borrowed from machine learning, artificial intelligence, and electronics. But we also use tagging algorithms that are more similar to natural language processing than to other psychometric algorithms with which we are familiar. And then in a separate step, we might have the estimation of the ability, which may still use IRT-like models. So there are two separate approaches. So one is, how do we adapt? What algorithm are we going to use to select the next instructional module? And the other question is, how are we going to estimate the ability? The framework in which we think about at ACT Next is computational psychometrics. And in this particular case, what that means is that we are bringing together the conceptual frameworks and the cognitive models from psychology. We blend them with the CAT or MST algorithm for estimating the abilities, but we also use machine learning algorithm especially for selecting the next instructional module. So this is why the computational psychometrics is a framework for our thinking. So we look at the elements of telemetry, so very fine data levels. Then we try to extract the features using traditional data mining tools. And then eventually we can use this information to modify the higher level constructs and to refine our student model and cognitive models. So in this case, especially for the selection of the next instructional module is where we will use the feature extraction and the telemetry that we propose. So I want to, this is actually the representation of a very big project at ACT Next. And this is what is called the Missing Link project. But it has components in it that I believe are quite relevant to this audience, not only because there are adaptive elements into it, but also because it emphasizes where we need to go once we start taking advantage of the large data sets that we have. So let me first step back and say when I say data or educational data, what I mean are two types of things. One is a large pool of items, the way Angela, for example, talked before. But beyond that, I'm also talking about large pool of content. I'm talking about having content available for instructional purposes. And that's quite challenging, obviously. But then I'm also talking about educational data on the other side. So any assessment is a match of items and people. And it's the same about learning. It's a match of content that has to be learned, but also people, abilities, and behaviors. So this system here, that I will go through details on it, is actually trying to capture all these elements. So let me emphasize what we have here. At ACT, we have this LEAP. This is a learning analytic platform on which we put all of our data at ACT. It's a new platform, and it contains cross-sectional data, such as data from tests, say ACT test, or the WorkKeys test, or some other test. It also contains those AOP and OPL data are learning data. They are data from the learning system, say test preparation materials. But we have also other types of data, such as data from social emotional learning instruments. Now, the beauty of this data is not that it's just a repository or a dump, but we are working really hard to have this data matched at the student level. So, in other words, if we have a student that interacted with one of our tests or more than one of our tests, we should have that data in a vector per student, or at least be able to pull it up at the student level. Another capability at ACT, it's of a different nature, and it's called the ACT's holistic framework. This is a theoretical framework that has been developed by the researchers at ACT in the past 10 years or so, and it describes the type of skills and sub-skills that are necessary for students to be successful in schools and in career. The nice part about that is that our instruments at the item and content level are being tagged to this holistic framework, which is quite detailed, it's quite fine-grained. So you have a hierarchical structure per skills, sub-skills, and so on, and it's a relatively fine-grained. And we matched all of our instruments to that content. This is actually quite an important piece for what I'm trying to say today. Then on this side, we have part of the elements there are what ACT Next is doing at the moment. in my team. So what we are doing, we work on developing diagnostic models and feedback models. So the way we do that, we develop diagnostic models in the traditional psychometric way, using the cross-sectional data. For example, if the only data that we have about the students are testing data, then we will use one of the cognitive diagnostic models for those testing instruments. But in addition to that, as I mentioned before, we have access for some students to test preparation data. So those are learning data. And for those learning models, we will have different types of diagnostic approaches. And those are, as I mentioned before, learning models. In our case, we started with the ACT test, and we worked together with Jimmy De La Torre, who is one of our consultants, to develop models for a cognitive diagnostic model for the ACT test. And we started to look at the model called Bayesian knowledge tracing for the test preparation data. So that's still in progress. And now, most recently, we started working on developing the right models for another set of assessment that's called the work keys. So we are also using a GDNA-like model. But then we also put together a feedback model, which is still in progress at the moment, because the feedback model depends on what type of data we have about each student. In addition to having the data from the testing data or learning data, as I mentioned before, we might have other types of information. And what we are going to use would be the learning analytics tools to identify the behaviors that students display while they are interacting with the systems. So these are all happening in 3 and 4, in the diagram 3 and diagram 4. Now, another interesting aspect is actually what's happening in 5 and 6. And I did present some of this work before, but most recently we made a lot of progress, especially on bringing this 6 back into the data and identifying the work, the adaptive work that's happening at this level. So let me explain. So if we have a feedback model for a student, and we will say, we are able to provide information at the cognitive diagnostic model to some extent, and we'll say, this is where you are with respect to addition or multiplication, then we are using another capability of the company, which is called OpenEd. OpenEd is actually a company that ACT bought about 2 years ago, and OpenEd is a platform for educational content. The nice part about that is that this educational content has been tagged on one side with the common core standards, and on the other side with the holistic framework. And moreover, this content has been tagged at a very fine grain level. So what happens then with our diagnostic model, we will tell people that you need to work more, say, on divisions. But because the OpenEd, and because we have all that information about the items that have been tagged with the holistic framework, we can actually identify which items the student actually got wrong. And then we can go directly to the OpenEd resources and select instructional content that will target exactly those types of items that the student got wrong. So this is the type of adaptability that I'm actually talking about, and it's a bit different than everything else we considered as adaptive before. And it's working through tagging as in a natural language processing approach. Another new feature in this system is that now we are able to capture the data back from the OpenEd and put it back into our LEAP platform. And just to make it all nice, everything is on a mobile platform, so there is an app that is available for test takers to interact directly with everything else that's happening in the back. But the purpose of, and here I have a lot of details here, but the focus of my presentation for today is to show a type of adaptability and adaptivity that is different from the way we've been talking about in adaptive testing before. But on the other hand, it does use some of the conceptual ideas that are common in this audience. So another thing I want to emphasize is that this tagging, as I mentioned before, of the content has been conducted using machine learning tools based on the text. So in other words, if they have an instructional module as a video, then they will do, first they will do speech to text, and then they will use this, as I mentioned in computational psychometric slides, they will use this feature extraction. So what are the features that are relevant for that particular text? And then those will be aligned with the similar type of tagging that took place on the holistic framework and on the other side on the standards. So this is how we are. I think I mentioned most of this. I just want to give, this is a bit more organized here, because before I've just done it showing you on the picture. So these are the 3 elements of the approach for the diagnostic model and for feedback. So this part is not adaptive, with the exception to some extent of the learning model that needs, of course, to take into account the change in ability. But the other ones are not adaptive in the sense of how we are talking about. And this is a bit more to present details about how a cognitive diagnostic model here would work in our case. So we are trying to, and this is based on the math, but it's not the final Q matrix that we have. It's just an example. And we did try to, so we look at different models, and we selected, at this point in time, we do have the Q matrix for math established. So we have a mapping between items and attributes for all ACT tests, math sections. What we are working on is to make this assignment automatic, so that from test form to test form, you automatically get the mapping between items and attributes. And part of that work, by the way, is also going to use more of the content tagging than anything else. So that's one priority for us at the moment. This is just to continue, so it's nothing really new here. This is the difference, of course, on how a profile would, how the Q matrix may look and what type of models we considered. Here is how this feedback would look at a student level in terms of probabilities and skills, and here is how the information would look across students and what type of profiles we can identify. So now the type of models for learning that we were looking at. So one, we started to look into the Bayesian knowledge tracing. The other one is the ELO system as well. So these are the 2. But in this case, the one with which we actually started is the BKT, which pretty much is a similar model like a hidden Markov model. So it's for a particular skill, and given a student's response to a sequence of items, you want to predict the response to the next item. And the original BKT method was for dichotomically score item, and that each item targets a single skill. So as I mentioned before, it does look a bit like a simple hidden Markov model with 2 states, the not learned skill and the learned skill, where different probabilities of transitioning from one state to the other will need to be estimated. And you have the observed information about whether the student responded correctly or incorrectly to that particular question. So it is more like a 2-state learning model. And it has 4 parameters. And in the original version, the probability of forgetting was assumed to be 0. So this is the model with which we are working right now. And of course, it's traditionally it's estimated in a Bayesian framework, so we would work with that. At the moment, we put that part aside, partly because Gunther Maris joined us, and he has experience with the ELO rating system, so now we are going to look to see whether that's going to be more useful for us. But partly because we are running a pilot at the moment, and those students in our pilot do not have any learning data. So therefore, we have to focus more onto cross-sectional type of cognitive diagnostic models. So on the learning analytics, we also are able to already collect some of this data, because I mentioned before that we created a mobile application. It's an app, and the student interacts directly with this app, including when we send the student to take watch a video or play a game or some other educational content. So we are able to collect information about how much time the student spent, whether the student interrupted herself while watching a video, for example, whether the student actually followed the recommendations that we gave. So there are some of this level, some of this data that come automatically through the use of the app. In addition to that, we are also going to have other behavior analytics, such as based on persistence or curiosity. For example, in the learning environment, the students have the opportunity to go and search or practice different things of their choice, or they can only follow the recommendations that we gave them. At this moment, we do not have the social learning analytics in place, but this is the plan to build that as well. And of course, we hope to be able to develop predictive analytics both within the student, but also across students, especially because teachers expressed an interest in this tool. So I think I'm going to skip this one. So the main message for today, I guess, is related to this green link here, is that we want to link the diagnostic and feedback model to remedial resources in an adaptive way. And all of this, as I mentioned before, is in this framework of computational psychometrics. So how would this adaptive learning work in our system, the one that I showed you before? So the student would receive a profile like this, as I showed it before. And then we know exactly which items the student got wrong at each attribute level. So addition, subtraction, and so on. There may only be very few items at that level. So we are not confident to make a claim and tell the student, well, you really don't know fractions, because we may only have had 2 items about fractions. But what we can do is to actually identify the description of that item or those items that were wrong and link those to describe them at a very fine-grained level, and then link those to the open-ed similar tagged content. And then we read this content of the items that were wrong under each attribute, and we search for the matching content on the open-ed in real time. So with that, we are able to provide the student with a set of remedial recommendations for each attribute based on the items they actually got wrong, but also based on an efficacy system that is part of the open-ed offered. So open-ed over time was able, because they have so many students taking these instructional modules, and because they offer small quizzes at the end of different instructional modules, they were able to build an efficacy index for all of their offerings. So now when we make a recommendation to a student, we will get the first 5, for example, or 3 recommended instructional modules that have the highest in a decreasing order of their efficacy index. And these resources can be of many types, as long as we are able to translate their description into text, because that's how all the tagging took place at the text level. So even if they are videos or games, they have to have a description that is text that is further linked to standards. So now the student will be able to interact directly with this content through the API, and there are also quizzes that are associated with also these fine-grained sub-skills that are available in OpenEd. In general, the quizzes are relatively short, so they might not be very reliable, but if you see that this is part of a full learning environment and system, then we will get more than just a few quizzes per student, and therefore I believe, that's of course it's an empirical question, but I believe that that data would be sufficient for for building appropriate pathways for the students. Now, in addition, we also have the behavior data and the quizzes responses from the OpenEd that will come back into the LEAP. And then we monitor whether the student will actually follow our recommendations. All of this data will be used to refine the diagnostic and the feedback model that with which we initially started. And the nice part about it, which is actually one of the best features of all of these new big data machine learning systems, is that the more you use the system, the better it's actually going to become, because you increase your data and you have more information. Again, it's an empirical question, so you should ask me about that in 2 years, probably from now. So where are we right now? We do have the Q matrices and the holistic framework aligned for the ACT tests. We are having a pilot right now, as I mentioned before. We started with the ACT test because this is what the students took. That was the first data set that we had on these students. And we are doing the same for the work keys assessment, because these students took the work keys. We are also doing the same alignment for Tessera. ACT Tessera is our new assessment, which will go live in the fall for social emotional skills. So we will have this Q matrix alignment also for Tessera in this, especially because of our pilot. Now, the OpenEd educational content has been already been tagged to the Common Core and to the holistic framework. It doesn't yet include sufficient social emotional learning materials, so that won't be available for our pilot. We also have a crude BKT for the ACT test prep data, but we probably we will need to wait on that until we finish the pilot and we have students that actually went through the test prep. And we have now that the OpenEd data will be collected through TAO, and we are, so they also work very hard at getting all of their data in the Caliper standards, which is quite helpful. You know, if you listen to the presentation this morning that Angela gave, you know, it kind of matters what type of standards you use and how you collect your data. And we don't have it yet. We don't have yet that loop completed, that the data from the OpenEd will get back into our platform. But this is going to happen in the next few months. So we are also able at this moment to make recommendation of instructional content in real time on the app. We have the app as a prototype. It's developed. It's available on test flight, so not everyone can actually play with it. You need to receive an invitation to start playing with it. And the pilot, as I mentioned, officially will start in September, but we already received the information about the students who will participate, so we know what type of data we have for them. And, well, this is just the app. So to conclude, I want to emphasize in this presentation different type of approaches to adaptive learning. So, of course, there are ideal situations in which you might start all from scratch, build a pool of content, build another pool for testing, and then play with all types of fancy algorithms. In some other ways, if you want, my approach to adaptive learning here is pretty much let's use what we have in-house, because we have some capabilities that are really good. And let's think a bit differently about what adaptivity means. So in our case, we went to psychometric models, and we took the cognitive diagnostic models. Then we went to economics and took the learning analytics. And then we went to NLP and machine learning to use their approaches to content tagging. And I think this is quite powerful, but it's definitely different, not only from what is presented here, but also about how people have been talking about adaptive learning systems, where everything has been done at a relatively small scale, and with content that was painfully developed by different teachers. Here, again, I want to emphasize the value of crowdsourcing in a way. Think about that this content has been actually crowdsourced. This OpenEd has a platform, an API, that allows other providers to put their content there. So this is such a new way of thinking of what is educational content. And of course, you can criticize it. I mean, there are many things to criticize. You can start with, well, what about the quality of that content? I mean, that's the first place to start. So sure, remember they built this efficacy index for monitoring the quality, and they have a threshold. So if after a period of time that efficacy index is low, then that content will not be available. Or it will be available, but only like position 200 or so, once recommendations are made on which content is the best. Another complication could be, what if our tagging or recommender algorithm that is only based on content and to some extent on difficulty is not very accurate. So let's say the ability of the student is here, but I recommend content that's still a bit too easy or too hard. Well, that could be unpleasant, but given the learning purposes here, I think for the recommending part, that's probably, we can accept a bit of a larger error margin on this level. And again, for the ability estimation itself and for the cognitive diagnostic model, where we will make claims about people's ability, we are still using our traditional psychometric approach. That being said, we are also doing research on that. So we have a few projects with Jimmy. One project that we are looking at is using the whole system that I presented. One question is, what if with my cognitive diagnostic model on, say, the ACT math, I can't provide the full information for the student with respect to a particular subskill? Can I use some of the quizzes from OpenEd to augment that information? So this is one research project that we are looking at. Another project we are looking at are, can we look at covariates to improve that information? So, and to some extent, some of this data and approaches are done post facto, especially when we are talking about the testing data. But as we go and have more of the learning model, then we are going to move into in real-time data. I want to emphasize that this is a very large team working on that. We have people from ACT Next, but also other people from ACT, from psychometricians and test developers and learning scientists. And from the OpenEd team, we've been working very closely with Adam Bloom and his colleagues. And our consultant here is Jimmy, whom you know. And we also have a business developer and program manager of the project. So it's a large team. Thank you for your attention.
May I ask we do the questions after the presentation, if that's okay? Okay, thank you.
Hi, my name is Helena. I'm going to be the last presenter for today's symposium. The topic I'm going to describe here is quite different from the previous, I would say, 3 presenters. Here we are looking at a different question, a different way of construct what does that mean when, as a practitioner, we want to apply MST design in a real test. And what other parameters we have to constrain ourselves as psychometricians, and what parameters can actually move, and what will be the solutions or questions for the audience today. I would just start with the context here is in the domain of large-scale survey assessment. So instead of providing an accurate or better predictor of how students' proficiencies are, this type of assessment focuses on group-level assessment. So there's no student scores. The focus will be, for example, internationally across countries, or within United States, different districts. Why do we want to even consider adaptivity here? I would say there are two major motivations. First, think about United States. There are a wide distribution across all the states, all the districts. So the program we are focusing on in the United States always sort of want to make sure the low-performing areas are covered or better reported out. And there's also a motivation, an engagement issue that if you can improve the engagement through students participating in a survey assessment, which has little or no impact to their academic performance, that there could be a plus at the outcome of the MST design. And a little bit more background in a way to give the audience a sense why we want to solve certain questions in MST design. Here, I would say the most important feature for survey assessment will be the trend. So I gave an example for the United States survey assessment called NAEP. And here the program has built up decades of score tracing the populations of the United States and for different states and demographic information. So what we don't want to do is to change a different design and start to say, now the trend cannot continue. Your score from a new design cannot be compared back to 10, 20 years ago. So that is sort of the primary goal when we want to implement a new design. Are we changing how the program has been doing really well? I would also say that those skills from different years are linked through concurrent IRT calibration. So instead of we assume a pool of items with known parameters, we actually will do the live calibration, live not in a sense of when student testing, we gave them scores, but live in a sense when we finish assessment, we link scores through re-estimating the item parameters. That created a challenge when you talk about MST design, that we are doing something, I would say most of the practitioners here or faculty will tell me, don't do it. You can't calibrate item parameters within MST design. But given the current structure of survey assessment, there is a need to see if we could actually do that with the design we have in mind. A couple more constraints before we really get to the question, that those assessments, survey assessments, there are tight, I would say, frameworks and specifications to define what can be reported on. And in that particular case, I have an example for mathematics. So there's the overall scale and there are sub-scores coming from this assessment. So you can see we want to report quite detailed levels from a test. And do so, I will skip this part. It's sort of a different aspect for how we conduct the test. We have to implement a matrix sampling to make sure every student only take a small portion of the test, but the whole test is long enough to cover the framework. So here are all the constraints I just presented. Then let's go back to the question. Can we still do MST design? In a way, we put the design up front that is adaptive. And we can still do all the things we have been talked about for the program, like keep the old, bring you new, and without changing what NAEP has been reported on. Well, we tried that, and we certainly learned some good designs and not so good designs, and continue to improve. So the question presented to psychometricians will be, now if you really want to calibrate items from MST design, what you run into will be there's some certain items, especially at the second stage, given to a restricted range of abilities. That's what MST is doing, right? The high-performing students get a harder item, and low-performing students get easier items. So by design, you have a match for certain type of difficulty levels matched to certain range of ability. And is that a problem when you try to estimate item parameters? So we want to see if that's something doable in practice, given that we know we have a restricted range of abilities, and we have also fewer per student per item. Fewer per student items at the subscale level. So for each content domains in mathematics, I said before that you don't have tons of items to estimate the student ability. Will that be a problem? And whether you want to build in some common items between different target levels, which often not done for MST. Those panels and often distinguish mutually exclusive from each other. But maybe you need some common items across difficulty levels to be able to, what I described, estimating item parameters with the design. All right, so here is what we did. We did quite some simulations prior to a real data collection. And we have been working with some folks, even in this room. I was just looking at Hua Chang was there, and Gage Kingsbury was there to help us kind of figure out what is feasible. And what we did is in 2015, we did try a few trials in the effort for this program actually to move from a paper test to digital test. In a way, this design allows us to check out a few things for MST as well. And so that's the test design I have. It's a mathematics test in grade 8. We have 5 subskills. In total, there are around 170 items in the pool. And there are some multiple choice items and construct response items. So for each student, they received 2 blocks of items, and each block is around 17 or 18 items. All right, so what is the MST design we have in place? We have basically a 2-stage MST design, which work nicely with the NAEP testing design. In a way, students in a linear non-MST setup already receiving like 2, you can call that blocks or modules. In the past, those are non-adaptive. Now we can just easily adapt the current structure, make the first module the router, and the second module the targeted block. And the whole test, by the way, is like 60 minutes. So you have 30 minutes for the router, which can be quite long. You have like 15 multiple choice items to be able to route to the second stage. So the routing itself is a rather sort of a good decision-making process there. I have the design on the other side. You have basically the routers, and you have second stage blocks. Those are easy, medium, and hard. And you can see those are the routers do pair with different target blocks. But there's some missing cells there. Like none of the targeted block will meet with each other. Of course, you don't want to give a student in MST design an easy block and a hard block. You want to start with router and the second stage. So that's the design we have. We tried 2 different sets of item calibrations with the MST design as described. One will be you have 170 items. You calibrate everything all together. assume mass is just one dimension. And the second approach is we tried 5 separate calibrations, one for each subscale, which is currently how the program has been handling calibration. And the models are a mix of 3PL, 2PL, and generalized partial credit. So what we want to see, if the exercise is successful, is that at least the discrimination or difficulty parameters are reasonably estimated from the design. And there are some distinctions for the B parameter estimating from the easy, medium, hard blocks. That's how you grouped easy items have the sort of the cluster of difficulty on the lower end, medium, hard. So we want to have the separation. And let's see what we find. Here is when you calibrate this 170 items all together from MST data collection. And I would say for the scatter plots, those are the difficulty parameters. You can see that on the x-axis from the parameters estimated from a non-MST design. And for the y-axis are the MST design data collection. So those are all 116 matching items. There are some items only appeared in one side, so I excluded them. I would say the estimation for MST design looks reasonably okay when you have a long router, lots of items, and you get reasonable estimates for difficulty parameters in comparison to you don't have an MST design, which we assume at the baseline. That's the goal you want to reach. What about the discrimination parameters? Well, it's still go along the 45 line. There are some sort of variations. I did that because the scale range is from 0 to 3 for discrimination, so you can actually see the variation, but I would say the pattern is across the 45 line. That means when you estimate the item parameter discrimination parameters, you get a fairly reasonable estimates as from a non-MST design. That's, again, we are doing pretty okay there. But as I sort of mentioned before, in the practice, we calibrate items by subscales. So what happens when you do that 5 times? Only take part of the items for the calibration, not the whole pool. Here is what you get for difficulty parameter. I don't know if you remember what you saw before. When you calibrate everything together, looks really nice, but then when you calibrate 5 times by subscale, you start to see something we as psychometricians does not really like. The difficulties sort of have shift. Easier item become easier, harder item estimate become harder. That's not what we quite want yet. And when you get to the discrimination parameter, you would say, oh, what is going on? Why there's some pattern that targeted items are like underestimated and routers are overestimated. So what we learned is, well, when you calibrate items all together in a single scale, you are okay to estimate parameters. But when doing that at the subscale level, when the information is not as sort of sufficient as you do things unidimensionally, you start to run into problem with item calibration, which put us in a pause like, are we going to implement MST design and still doing the by subscale calibration and still thinking our scale will hold from year to year? The answer seems to be, we're not quite there yet. So I'll just quickly go through we tried a couple alternative designs. The effort here is to increase the ability range for the pool of the targeted items. Like, for example, the easy items now we gave not just to the low performing student, but some of the medium performing students as well. So there are a couple designs which we tried, and we ran some simulations to see if it helps. I'll just quickly show you some results. And that is from a pure MST design. We know the difficulty parameters were poorly estimated. When we increase the ability range, you can see the estimation becomes much in line with the non-MST design. So that's a good direction to go. And also the discrimination parameter, instead of sort of having directional shift, here is coming back more in line with the non-MST parameter estimation. All right, so where we are here. So we learned some lessons that, well, when you try to do everything the same way as those survey assessments have been doing, and trying to implement the MST design, there are things you need to watch for. For example, where you're going to get your item parameters. That is not some of the programs concern, like we assume we know the parameters before we form an MST panel. But in the survey assessment situation, the idea is hopefully we can still do the concurrent item calibration with the MST design. So if we want to do that, we can't just go live with all of the sample being MST. There has to be some compromise. In a way, you will still be able to get somewhere to estimate your parameters. A safer model, operationally, we were just considering maybe you need a calibration sample along with the MST sample. Like the sample size we're describing here is quite large. In the NAEP situation, you have about 150,000 students in the pool. Well, you could set aside some calibration sample. It's not as desirable as the whole pool of students is going MST, but at least you can get your skill maintained year over year, so you can still report on trends. So we are trying out a couple designs, and hopefully I can report back in 2 years for how the survey assessment eventually lands. All right, thank you.
Questions?
I think you mentioned one of the solutions in PIAC that I mentioned also after the first talk. We used a concurrent calibration with previous rounds, and we used multistage testing. So I think part of the idea might be just to use your knowledge about the items based on maybe more stable populations or something like that. Because, yeah, well, we reused essentially 60–70% of the items in the multi-stage design. So from that on, we essentially had 2/3 of the sample being in a linear design, and then the multi-stage would simply be aligned with that. So that might be one of the options to try.
Yes, that certainly is something we are considering. Just have a part of your pool going non-MST and part of your pool go MST, and some of the sample will help to estimate the parameters. Thank you. Which one?
Thank you for your presentation. I have a number of questions. I was very happy, of course, with the result that the MST designs give complete parameter recovery when you use the complete calibration at once, because all the decisions are made on observed variables, and due to ignorability principles, that must be true. So I believe again in our item response theory. But what I wonder is what is specific in your situation for the situation in large scale survey, where you are only interested in fact in population distribution, in distribution between groups, and that is what is specific in your study for that, because it is a little bit in another direction, as we always talk here in adaptive testing. We optimize individual testing, But in large-scale assessment, we are not interested in individual precision, but we are interested in decisions of, say, population parameters. What is the relation of what you have done to that aspect? Could you elaborate on that, please?
Right, if I understand your question, first it's a question around when you set MST design, what's your criteria to make sure the population is benefited from the design? Yes, so that's one part I didn't go into detail here. So when you discuss about the cut points, like where you set a cut point for some student going to the easy block, medium block, or hard block, we can just look at the test information to get the optimal cross function for like the information cross from easy to medium block, because you also want to make sure the populations are reasonably covered. For example, the low regions, like think about United States, there are some low performing states, and you want to make sure those states are below maybe 2-3 standard deviations. They are getting the test that we intended for them to get to. So the decision making is a compromise. We set the cut scores looking at the test information function. We also looking at the population to make sure that you have reasonable proportion of students route to the easy, medium, hard. Because that's really the whole purpose for survey assessment, to make sure the lower end of the ability range, population-wise, get the items that target at their ability range. So that decision making is, I would say, it's not just a pure psychometrization decision. They have to look at the whole population, that where the subpopulation is being routed to.
Is a follow-up on Theo's question. So what if you consider concurrent calibration with multiple groups? I just think that if you would consider that, then you will take into account automatically in your calibration those large differences among groups.
Yeah, that's a very interesting question. If I understand this, I assume like one population for each year. Are you suggesting maybe there are like 3 populations?
Yes, that's what I'm suggesting.
Yes, that's actually the first thing we tried. And the results are quite interesting. Actually, the parameter estimation getting worse. I will be happy to discuss with you why. We had an interesting discussion with Miss Levy on this. And we went to sort of the missing data area, like what is the missing mechanism? And he had a recent paper nicely explained that case. It's missing at random. So it's different from if you have ethnicity groups or race groups. That could help you to define different subpopulations. But in this situation, you are using the ability to make a judgment for where it's routed to. It's different from the auxiliary information collected outside of the test. In this way, actually assuming one population might be a better way to go. But I would say that's an open question. We tried both ways. And all I can say for now, it seems the results line up with what Bob's paper has been describing, that one population is a better way to specify things. But he suggested actually to look at your items. You might want to give a different priors for the items, because now you know hard items is different from easy items. That's how you form the module, right? But so when you estimate item parameters, you might be able to do something basing like assuming you know about the items, not that I know nothing about the item. That could be a way to go. Thank you.
Any questions for the previous talk by Alina?
Can I? Yeah. Can I ask you some question? Not for the previous part of the whole sessions this morning. As a practitioner, I think I'm going to make another new test, a new CAT test in the future, maybe near future, maybe. It's a commercial one. And I'd like to know why are you promoting the the MST right now compared to the ordinary CAT test? What is good about MST? What's the motivation of buying MST?
I'm sorry, I missed some part of your question.
Okay. I'd like to know what's the advantage to develop the MST compared to the non-MST? What is the advantage of MST? That's what I'd like to know.
Sorry, could you repeat that? You meant I went to your talk. You talk about the program that you are doing with multi-stage testing with automated scoring.
Yes, yes.
That's the commercial thing you are talking about.
No, I mean, my question is very, very basic. What is good about
what is good about
their testing?
Okay.
Yeah. Why do you need this kind of test? Because this kind of similar like a testlet, right?
Okay, so why is multi-stage testing needed?
Yeah, what is good about
there are
it?
Lots of reasons. From the traditional linear test going to adaptive testing, it involves a tremendous amount of effort to give, to select item, to define item pool, to give the item and to give a score, and how to select item, what kind of item to select. All of those are in the automated CAT algorithm. And then in reality that multi-stage testing is a form between linear test and CAT that has close to the CAT estimation, efficiency, and adaptive, and all the advantages, and also carry the disadvantages of the, not disadvantages, some of the concerns and issues with the CAT. However, it provides a much more efficient way compared to linear.
No, if I have CAT, that's okay, right?
Yes, yes, yeah.
Yeah, I do have a CAT system, so I can go for the CAT system. I don't have to go to MST.
Yeah, it's just a special form. For linear test, you have one form and all the items.
So MST is kind of between a linear and a CAT.
Okay. Yeah, so we can talk more about it offline if that's okay with you. Any other questions? Yeah, Chris, and you have.
Yes, I have a comment / question to Alina. First of all, I think sharing the new realization of all this idea of learning, adaptive learning, you did at IACAT next with you and your team. You showed also how the adaptive technology can be adapted and used in the learning experience of students. And you showed how right level of content is selected given the test takers or students' ability level. And that's a good start, but my suggestion is selecting the content with the level of difficulty that's aligned with the test score is maybe not necessarily the most effective selection when it comes to advancing the students' proficiency or ability. Maybe we can go through all the contents and compute some sort of expected probability of test takers' chance to advance their ability given their pre-knowledge of other contents. And it would help. So the focus of selecting the content for learning would not just about matching the difficulty of content to the test student's ability, but it can be more about the chance of advancing students' ability with the presentation of the contents. What do you have any comments on that?
So first of all, I need to apologize. I think my ears suffered from the flight because I really couldn't quite understand your question acoustically. I think you asked whether, actually I'm not even very sure it's true, but I think you want to know more about how we think in terms of ability estimation. And in what I presented today, we haven't quite used the ability estimation. I separated the adaptive learning into the two parts, into recommenders algorithm for the content and then the ability part. But today I didn't talk about the ability because we don't have yet that data coming back so that we can update the information about the ability. So, but I'm happy to talk also offline more about that because then I can probably understand what you are asking. So I'm sorry about that.
It's okay. My just suggestion was not just about estimating test takers or students' ability. Once you know the ability and historical previous learning, courses of learning and contents that each student learned, given all that, we can select the next content to be learned by students based on the best chance of improving their proficiency instead of just matching the right level of content.
I think it's a good idea, and we'll probably do that once we have that information. At this moment, we don't know that. We don't know, for example, for the students for which we are doing the pilot, the only thing we know about them is that they took the ACT test or the work keys or both. That's all we know about.
I apologize, we run into the lunchtime. Mark has a question, but if you need to go, you're free to leave. I'm sorry.
Okay, I'll try and make this short because we're going to go run to another meeting too. So it's, but I'm going to make believe, since I used to work at ACT and I worked on developing these tests, I've heard every argument there is about why this is all a bad idea. So I'm going to believe, or make believe, that I'm a curriculum person as opposed to a psychometrician. And I'm going to say, okay, here's my argument. You have this test, and maybe there's 60 math questions that you've got on this test that you've administered. The 60 math questions are non-representative sample of the domain of curriculum. They're not a random sample of the set of items that could possibly have been administered. So that you've got this set of items, and now you're just looking at the wrong responses, and you're picking out some curriculum materials to go over and try and improve the ability of somebody who has gotten some items wrong. How would you counter the argument to say that what you've done now is really narrowed the curriculum because the person can only get the remedial instruction on the set of items they happen to get wrong on this 60-item test that's a non-representative sample of the curriculum?
I would say you are right. And I would also say you have to start somewhere. And this is where we have the data and we know we can actually act. But the second part of that is that we also have the test prep materials, which are much broader than the test, the items on the test. And we also have, in addition to the ACT test, we have other tests that also, if you look at the items across different instruments, you will see that they cover more than just, narrow slices of the curriculum. So yeah, it's a good point, but I don't think that it's realistic to say I'm going to start with a system that will cover the whole curriculum. I mean, you have to start somewhere anyway. So that's my answer. We also built, especially this app that I was talking about. Its name is the ACT Educational Companion. So it is meant to accompany the student from early ages and early years in school to career. So in order to build that vision, definitely we'll need to go beyond, well beyond the ACT test. So yes, I agree with you.
Thank you for the presenters and thank you for coming.